we are going to take a look at series today. Okay, we've already looked at sequences, and now it's time to look at the series. Now, when you talk about series, okay, we're talking about the sum of the terms of a sequence is called a series. Okay, the sum of the terms of a sequence is called a series. So, for example, when you're looking at, let's say, the sequence 2, 4, 6, 8, and 10, okay, this is a sequence. Well, when I add a plus sign in between them and I add them together, now you're looking at a series. Okay, the sum of the terms of a sequence is called a series. Okay, so 2, 4, 6, 8, 10, that's your sequence. 2 plus 4 plus 6 plus 8 plus 10, that would be a series. Now, there's two different types of series because we have two different types of sequences. Okay, there is a finite series, okay, which is the sum of a finite number of terms. So that'd be like this. Okay, we have a very specific number, 2, 4, 6, 8, and 10, and that's where we would stop. Okay, we also have an infinite series. Okay, if it is an infinite series, then that means it would continue on forever. Now, when you start talking about infinite series, you're going to start moving into what we call limits, okay, which if you've come from pre-cal, you may have already heard that word. You've probably seen it already. If not, then you will probably get there when you hit college. So, you would start looking at limits, but that's where the infinite series is going to come into play. Okay, now when we talk about our series, okay, we use shorthand notation to denote a series. Okay, when the general term of the sequence is known, we call it the summation notation. Kind of fun thing to say, summation notation. Okay, summation notation. So this is summation notation. So if you're looking at this thinking it looks a little Greek, well, it's because it actually is. Okay, it is the Greek uppercase letter sigma. Okay, that's what that big E, funky E looking thing is called sigma, and it's used to mean the sum. Okay, it's used to mean the sum. So anytime you're talking about math, or if you look at Excel spreadsheets, okay, when you see this little thing, that's what they actually use to say the sum of something. Okay, you use sigma. So this right here is our summation notation. Okay, and I'm going to give you a little example here first just to talk about what the pieces are. So if I have n equals 1 to, say, 5 of 3n plus 1. Okay, first of all, we're going to read it. The sum of 3n plus 1 as n goes from 1 to 5. Okay, so the sum of 3n plus 1 as n goes from 1 to 5. Okay, so that's these two things. This is basically my starting point. So this says I would start on the first term, and I would go to the fifth term. Okay, and we'll talk about what to do with them. But that's what that says, as n goes from 1 to 5. Okay, so the sum of 3n plus 1 as n goes from 1 to 5. This right here, this piece right here is that general term. Okay, so that's the a sub n that we've been working with this whole time, the a sub n. That's what this thing right here is, our general term. Okay, so this is shorthand notation. This is summation notation. You'll also hear it called sigma notation. It just depends on who you're talking to. Okay, but it's technically summation notation. So, let's take a look at some series. This says evaluate, okay, the sum of I minus 2 over 2 as I goes from 0 to 6. Now, they're going to put I because typically when you work with sigma notation, we use the I. Okay, it's no different than the n. It doesn't really matter. Okay, it's just I is what's typically used, so that's what we're going to use here. Okay, but I is going to go from 0 to 6. So 0 here is going to be our starting position, and this is going to be our ending position. Okay, so what do we do with them? You just plug them in, but not just 0 and 6, every single number from 0 to 6. Okay, So for instance, I'm going to start at 0, 0 minus 2 over 2. I just replace that I with 0. And then we're going to add, because this is a sum. That's what sum means. So we're going to add the next term, which is 1 minus 2 over 2. And then 2 minus 2 over 2. 3 minus 2 over 2. I'm going to have to come down here. 4 minus 2 over 2. 5 minus 2 over 2. 6 minus 2 over 2. And that's where I stop. Okay, so I plugged in not just 0 and 6, but every single number from 0 to 6, meaning every natural number, so every counting number. 0, 1, 2, 3, 4, 5, and 6. And I just plugged it into my general term there. Okay, so once I get here, though, I'm not done. I've only plugged it in. Okay, I actually want the sum. I want to know what all of these things added together are. So that's what I'm going to do now. Negative 2 over 2 is negative 1. Okay, 1 minus 2 is negative 1 over 2, so minus 1 half. 2 minus 2 over 2 is 0. 3 minus 2 is 1 over 2. 2 minus 2 is 2 over 2, which is 1. 5 minus 2 is 3 over 2. 6 minus 2 is 4 over 2, which is 2. Okay, and you can go through and do these in your calculator. 0 minus 2, negative 2 over 2 is negative 1. Okay, negative 1 over 2, 0 over 2, 1 over 2, 2 over 2, which is 1, 5 minus 2 is 3 over 2, and then 4 over 2, which is 2. Okay, now we're going to add all those numbers together. Well, negative 1 and positive 1 makes 0. Negative 1 half and positive 1 half makes 0. 0 is obviously 0, so I just have 3 halves plus 2, okay, which if you plug that in your calculator, you're going to get 7 halves. You can also actually convert this to 4 over 2. 3 plus 4 is 7. Okay, so you get 7 over 2. So when you add every term of this sequence, okay, if you add every term of this sequence from 0 to 6, you end up with 7 halves. That's your series. Okay, so let's take a look at one more. Okay, let's do one that doesn't have fractions in it. It might help. So I'm going to go from 3 to 5. So again, here's my starting position, and this is my ending position. Okay, so I'm going to plug in every number starting at 3 and ending at 5. So here we go. 2 to the third power. This is 2 to the I, so 2 to the third, plus 2 to the fourth, plus 2 to the fifth. So I just plugged in for I every number from 3 to 5. And you're adding each time you plug in a number. Okay, so now let's add that up. 2 to the third is 8. 2 to the fourth is 16. And 2 to the fifth is 32. Add those up and I get 56. Okay, so the sum of 2i from 3 to 5 is 56. Okay, and that's called a series. So I want you to try these on your own. Okay, hit the pause button. It should take you 3 minutes or so, maybe 4 tops to get these done. Okay, so do these, try these, make sure you can get the correct answer, and then hit play and see if your answer matches up with mine. Okay, so hopefully you hit pause and you're coming back. And I hope you did these, okay? You really need to practice these. They're actually not that hard, but it is good to see several of them so that you get used to the notation and what it actually means. Okay, so here I go. I go 0 minus 3 over 4 plus. Okay, I started at 0. We're going to do every number in between, just plugging in for that I. 2 minus 3 over 4. 3 minus 3 over 4. 4 minus 3 over 4, 5 minus 3 over 4, and 6 minus 3 over 4. Okay, let's reduce all of those. So negative 3/4, that's going to be negative 2/4, which I'm just going to leave it as negative 2/4. I'm going to keep my denominator the same, so I'm not going to reduce any of them. I'm just going to leave it negative 2/4. Okay, this is negative 1/4. That's going to be 0. Positive 1/4, positive 2/4, and positive 3/4. Okay, 0, 1, 2, 3, 4, 5, and 6. Okay, 0, 1, 2, 3, 4, 5, and 6. So when you do that, go through and see what cancels. I get negative 3 and positive 3/4, negative 2/4 and positive 2/4, negative 1/4 and positive 1/4, which is going to leave us with 0. Okay, so our answer there is 0. Okay, hopefully you got that. Okay, hopefully you got that. So 0 to 6. Notice I have 1, 2, 3, 4, 5, 6. There's actually 7 terms there because I went from 0 to 6, not 1 to 6. Okay, kind of interesting how that happens. So make sure when you're plugging in, you start at 0 and you end at 6. Okay, so now let's take a look at B. Okay, so for B, you're going to do the same sort of thing, only we've got a different general term. Okay, and I'm going to start at 2. Let me box this off since I went a little crazy. Okay, so here we go. 3 to the second power plus 3 to the third power, 3 to the fourth power, and 3 to the fifth power. Okay, 3 to the fifth power. So I started at 2, I ended at 5. 2, 3, 4, and 5. Here we go. 3 squared is 9. 3 cubed is 27. 3 to the fourth is 81. And 3 to the fifth is 243. Okay, add all of those up. That would give me 90. That would give me 117. That would give me 360. Okay, so you should get 360. Granted, you can use your calculator, which I hope you did. Well, you didn't. Not that I hope you did, okay? I like it when you guys don't use calculators, but hopefully you were able to get to the 360, whichever way you chose to get there. How about that? Okay, so 360 should have been your answer. Write out the 5 terms, just like we've been doing in the last 2 units, okay? Or the last 2 sections, I should say. Okay, you wrote out your 5 terms. The only thing that's happening that's different here is that I am now adding. Okay, that's all I'm doing different. I'm just adding them up. That's it. Alright, so now in example 2, we need to write each series with summation notation. Okay, write each series with summation notation. So the very first part of writing the series is going to be to write a general term. So I need a general term for this. Okay, so you can use our formula. So from 3 to 6 is plus 3, plus 3, plus 3. So it's adding by 3 every single time. That makes this thing arithmetic. Okay, so that makes this thing arithmetic. So I'm going to use the A1 plus n minus 1 times d. Okay, where d is this number and this is my a sub 1. So I'm going to plug those in. Now some of you guys may be able to look at this and see exactly what the general term is going to be without having to fill in the formula. That's fine. Okay, in this section you do not have to use the formula. You can go straight to writing an equation for this. So if you know that since it's jumping by 3 and it starts with 3, then it's going to just be 3n, then you can go there. If you don't know that just by looking at that my general equation is going to be 3n, then use your formula. Work it out. 3n minus 3 equals 3's are going to cancel and I get 3n just the same. Okay, so if you can't just look at it and see what it's supposed to be, work it out. Use your formula. Get your general term. Now once I have my general term, I can write my sigma notation, or summation notation rather. Okay, I am going to switch to I, just because I is what you typically use when you use summation notation. Okay, so that's my general term, is 3i. Now I have to figure out I equals what? Okay, well, when I plug in my first number, I need to get my first term. Okay, so if I plug in 1, 3 times 1 would be 3, I would get 3. So I have to start at 1, and then I've got 1, 2, 3, 4, 5 terms, so I'm going to go to the 5th. Okay, so from 1 to 5. And you can check that. If I plugged in 5, 3 times 5 would give me 15. That would be my last term. Okay, so 1 to 5. Okay, so one more time. This number, when I plug it in, needs to give me this number. Okay, which it should. So I'm almost always going to start with 1 on those. Okay, they are going to give me stuff where I start with 0 or 2 or 7 or stuff like that. Okay, when they give me stuff, they're going to start at different numbers. Like here, they start at 0. When we write ours, they're almost always going to start with 1. So your best bet is just start with 1 and then count the number of terms, and that's what goes on top. Okay, so let's look at another one. So 1/2, 1/4, 1/8, 1/16. Well, this is doubling. General term, a lot of you guys know that this can be written 1 over 2 to the n. Okay, if you didn't know that, use your formula, and I want to show you something because this confuses a lot of people. So when you use your formula, okay, your general formula for this is going to be a1 r, sorry, you can't see it, r to the n minus 1. Okay, where r here I'm multiplying by times 1/2. Times 1/2. Okay, so if I do this, I would get a1 is going to be the first term, which is 1/2, times 1/2 raised to the n minus 1. Now remember I said you cannot multiply these together. I cannot make this 1/4. Okay, but notice these two things are different, and let me show you why. Okay, the reason why they're different is because technically I have two bases. So if I had x times x, I would add the exponents. 1 plus 1 is 2, so I'd get x squared. Well, here my bases are the same. They're both 1/2, and this technically has an exponent of 1. Okay, so when I multiply my bases, I add exponents. So what I get here is 1/2 to the n minus 1 plus 1, because I add my exponents, which just means 1/2 to the nth power, because negative 1 plus 1 just goes away. Okay, the only difference here is that I've got the parentheses, but 1 to any exponent is just going to be 1, so I could rewrite that as 1 over 2 to the n. Okay, now all of that being said, you can easily put this in here, okay, 1/2 times 1/2 to the n minus 1, and it will be correct. You will not lose points for that. So if you do your general term and you do this as your general term, that is perfectly fine. Okay? But I want to just show you, if you were just figuring out that it was doubling, so you just put this and you saw that they were different, I wanted you to understand why they were different. Okay? They actually are the same thing, just written in a little bit different manner. So, alright, so I'm going to use this one, the 1 over 2 to the n power. So I still need to write my summation notation. So I need my sigma. Okay, I have 1 over 2 to the I power. Okay, I switched it to an I again. I is going to go, I said start them with 1. Okay, because when I plug in 1, I'd get 1 over 2 to the first, which is 1/2. And I'm going to go to 1, 2, 3, 4 terms. Okay, not 16, nothing like that. It's the number of terms. 1, 2, 3, 4 terms. Okay, so from 1 to 4. And again, you can check. When I plug that in, I'd get 2 to the 4th power, which is 16, so 1 over 16. Okay, all right, now there are 2 on your own, but before you start, there is an error on B. So please fix this before you get started. On B, the second number should read 25. 1 over 25, not 1 over 10. So please make that correction first. And now, hit that pause button, see if you can do it. Come back when you have your answers. Alright, so hopefully you did these already. Write each series with summation notation. Okay, so here I go. I'm going to start by writing a general term, so I need to figure out, is it arithmetic or is it geometric? Okay, this is plus 5, plus 5, plus 5 each time. So this is going to be arithmetic, which means I'm going to use my arithmetic formula if you need to. A lot of you, again, might see that this is 5n. Okay, it's 5n. It starts with 5, so it's just going to be 5n. But if you didn't see that, then plug it in. A sub n is 5 plus n minus 1 times the difference, which is also 5, which is 5 plus 5n minus 5, which is just 5n. Okay, so you get your general term here is going to be 5n. So sigma notation becomes 5i. Okay, again, if you left it as n, that's fine. You're not going to lose points. Okay, but it's proper notation to use I. That's the only reason why I keep doing it. Okay, so 5I, we're going to start with 1, because when I plug in 1, I should get my first term, which 5 times 1 is 5. And then I have 1, 2, 3, 4, 5, 6 terms. Count them out. 1, 2, 3, 4, 5, 6 terms. So the sum of 5I from 1 to 6. That's how you write that in summation notation. Alright, so then the second one, once we made our correction of 1 over 25, okay, so that means we're going times 1/5 each time. Okay, times 1/5. So that makes this thing geometric. I don't know why I said it like that. Geometric. Okay, so geometric. And if you can't see the pattern, go ahead and plug it in. So I get 1/5 times 1/5 to the n minus 1. Same sort of thing. 1/5 times 1/5 to the n minus 1 is just going to become 1/5 to the nth power. And I can drop the n on the 1 on top. So sigma. So I get 1 over 5 to the I, or, okay, or you can just do, you can leave it as, and I'll just show it to you here, 1/5 to the I power. Those are exactly the same. It does not matter which one you chose to do. Okay, those are exactly the same. So once I get there, I have to figure out what my starting point and my ending point are. Okay, I'm going to start with 1 again, because when I plug in 1, I'd get 1/5 to the first power, which is 1/5, and I have 1, 2, 3, 4 terms. Okay, 4 terms. Sorry, it's a little crooked. So from 1 to 4. So the sum of 1/5 to the I power is equal to, or from 1 to 4. It's not equal to anything. We didn't figure that out. We were just writing summation notation. Okay, so now we have to look at something called partial sums. Okay, we have to look at partial sums. And we're going to look at these just briefly today. We'll look at them more on Tuesday after prom, which, by the way, have a good prom, be safe, be careful, all that great, wonderful stuff. All right, so partial sums, we're going to introduce it just a little bit right now, and then we'll look at it more on Tuesday when you come back. So the sum of the first n terms of the sequence is a finite series known as a partial sum. Okay, a partial sum. Okay, so the n terms of a sequence is a finite series known as a partial sum. So basically, we're only going to be looking at part of these things. Okay, and we denote that by S sub n. Okay, where the sum is from 1 to n. Now this gets a little confusing because now I've got an I and an n. That's why we switched the other ones to i's, because now we've got an n value up here. Okay, so let's take a look at example 3. Okay, so they want us to find the sum of the first three terms of the sequence whose general term is a sub n is equal to n plus 3 over 2n. So the first three first three terms, okay, you're looking at that partial sum, okay, of 3. That's what that means, the partial sum of the first three terms. That's what that S means. Okay, so that is going to be the same thing as the sum as I goes from 1 to 3 of a sub I. When they say a sub I, they mean your general term with I in its place. So instead of n plus 3, we get I plus 3 over 2 times I. Okay, 2 times I. That's a 3 up there. It kind of got a little messed up. It is a 3. Okay, so then from here you should be able to do this. This is what we've been working on. So this is the sum from 1 to 3 of this general term. Okay, so plug in your numbers from 1 to 3. So we get 1 plus 3 over 2 times 1 plus 2 plus 3 over 2 times 2 plus 3 times 3 plus 3, not times. Can't seem to do my work now. 3 plus 3 over 2 times 3. Okay, so now we need to work all of that out. That would be 4 over 2 plus 5 over 4 plus 6 over 6 Okay, so that's actually 2 plus 5/4 plus 1, which is going to be, okay, that gives you 3 plus 5/4, which is 12 plus 5/4, which is 17/4. Okay, a little off my screen there. Okay, so we've got 2 plus 1 is 3 plus 5/4. You can change this. You can use your calculator, of course. Okay, so I put it over 1. I did times 4 top and bottom. So I got 12/4 plus 5/4 is 17/4. So that would be your answer. So the partial sum is 17/4. The partial sum of the first three terms. Okay, the partial sum of that first three terms is going to be 17/4. Alright, there is an on your own there. Okay, I want you to give this thing a try. It shouldn't really be all that bad. It is the same thing we've been doing. It just has a little bit different notation. Okay, so we're looking at that partial sums. That's what that thing means. You just need to know that when you see S3, that means the sum from 1 to 3. So, give that on your own a try. Hopefully you hit pause. Hopefully you tried this. Find the sum of the first three terms of the sequence whose general term is a sub n, which is equal to 3n plus 1 over n. Okay, I'm a little crooked. Let me straighten that out. So find the sum of the first three terms of the sequence. So they want 3. S sub 3. Okay, that's what that means. Of the sequence whose general term is a sub n is equal to 3n plus 1 over n. Okay, so that means the sum, as I goes from 1 to 3, of 3i plus 1 over I. Okay, I just put my general term here with I values. We're going to go from 1 to 3 because they wanted the first three terms. Plug those things in. 3 times 1 plus 1 over 1 plus 3 times 2 plus 1 over 2 plus 3 times 3 plus 1 over 3. Add that up. That's 3 plus 1 is 4. Okay, that would be 6 plus 1 is 7 over 2. And that would be 9 plus 1 is 10 over 3. Okay, when you add all of that up, you should get 65/6. Okay, again, you know I don't want decimals. I never like decimals. Give me fractions. Use your calculator. Hit the math fraction button. Okay, if you don't know where that is, ask somebody. I'm sure there's somebody near you who can show you exactly where that's at. Alright, so example 4. The number of baby gorillas born at the San Diego Zoo is a sequence defined by a sub n is equal to n times n minus 1, where n is the number of years the zoo has owned gorillas. Find the total number of baby gorillas born in the first 4 years. So we talked about the puppy weight, and I told you there was going to be a difference in the weight the puppy gained in the 5th month versus the weight gained up to the 5th month. Okay, so now we're at that point where we're not looking at the number of gorillas born in the 4th year, okay, but the number of gorillas born in the first 4 years. So now we're going to sum these things. So you have to read these things carefully to see if you're going to be adding them or not adding them all together. Okay, so they want a partial sum here of the first 4 years, which means the sum starting at the 1st year to the 4th year of, and we're just going to use that general term, only we're going to use I. So I times I minus 1. Okay, so here we go. Plug those in. 1 times 1 minus 1 plus 2 times 2 minus 1 plus 3 times 3 minus 1 plus 4 times 4 minus 1. That's my stopping point because that's where I ended. I wanted the first 4 terms. 1, 2, 3, 4. Now work all of that out. 1 minus 1 is 0, so the first one's 0. 2 minus 1 is 1 times 2 is 2. 3 minus 1 is 2 times 3 is 6. 4 minus 1 is 3 times 4 is 12. Okay, so add all of those. Don't stop there. You add all those up. 2 plus 6 is 8 plus 12 is 20. So in the first 4 years, we're going to have a total of 20 baby gorillas. That's a lot of baby gorillas, and they are adorable. I like them. All right, last on your own here for the day, and then we will pick all of this up on Tuesday. Here we go. Hit the on your own. Hit the pause button. See if you can't do it. Come back. Hopefully there's enough time. Alright, so if you came back, the number of strawberry plants growing in a garden is a sequence defined by a sub n is equal to n times 2n minus 1. N is the number of years after planting a strawberry plant. Find the total number of strawberry plants after 5 years. There's that key word there, total. Okay, we are looking for that total number. So we want the partial sum of the first 5. Okay, which means the sum from 1 to 5 of this right here, I times 2I minus 1. Okay, so starting at 1, ending at 5. Here we go. 1 times 2 times 1 minus 1. 2 minus 1 is 1 times 1. We'll get there in a second. I don't know why I'm trying to do them all at once. 2 times 2 minus 1 plus 3 times 2 times 3 minus 1. It's kind of hard to say. Plus 4 times 2 times 4 minus 1 plus 5 times 2 times 5 minus 1. Goodness gracious. Okay, here we go. 2 minus 1 is 1. 1 times 1 is 1. 4 minus 1 is 3. Okay, so this is 3 in here. 3 times 2 is 6. 6 minus 1 is 5. 3 times 5 is 15. 8 minus 1 is 7. 7 times 4, 28. Goodness gracious. 2 times 5 is 10, minus 1 is 9. 9 times 5 is 45. Okay, now take all of those and add them together. So I get 7, 22, 50, 95. So I get 95 total strawberries, or strawberry plants rather. Okay, no, I'm not going to take off points if you don't write strawberry plants, in case you were wondering, because I know you are. Alright, so that's the end of sequences, or series rather, and I will see you back on Tuesday after prom. Again, be careful, have a good time, enjoy. Maybe, if I can make this thing shut off.